Then we have a simple linear regression model. For a simple linear regression model, as we said before, it's a linear equation. It's a linear equation. It's a relationship between two variables. Okay? We have y1 equals alpha plus beta xi plus epsilon I. Here, in the linear equation, we see y equals mx plus b. This is the linear equation. Linear regression is also a linear equation. It's a linear equation. But here we have this error. This is error. This is error at each step. And here, m is what? M is the slope. Is it? What's which of these alpha and beta represents m? Beta represents m. That means beta is the slope. How about alpha? Alpha is y-intercepts. It's y-intercepts. يكتب رينستونية. يكتب رينستونية لمن هي لا how شيء earlier. So alpha is the intercept point. It's the intersection of the graph with respect to y-axis. It's y-intercept. These are the what I said. It's nothing actually. Here, module assumptions. The assumptions underlying the simple linear regression model include the following. We have these in it. The errors, which denotes by epsilon I. Epsilon I is the errors. These errors are normally distributed. These errors must be normally distributed. Then the mean on the random errors must be 0. The mean of the random errors must be 0. And also the variance of the random errors is an unknown. Here the variance is unknown. Then the errors are uncorrelated. That's the covariance of epsilon I and epsilon G is 0. There is no any relation. These are not correlated. They are not near to each other. Okay? For example, let me tell you what's the correlation. If we have these points, these are correlated. Okay? Because if we draw a line like this here, all the points are near to each other. Okay, but if you have, let's say here, correlated, it's spread out. Okay, this is not correlated. It's the same here. It says the errors are uncorrelated. We now have fitted a simple linear regression. As I said, y is alpha plus beta x plus epsilon. Epsilon is the error, beta is the slope, and alpha is the intercept, y-intercept, I mean. This is the rule. Y hat equals, we just write down this without the error. We don't use the error here. Y hat equals alpha hat plus beta hat x. We just use by beta hats. Okay? We say y hat equals alpha hat plus beta hat x. We have this rule in solving the examples. The most important thing here is to find the values of alpha hat and beta hat. Now, we talk about how to find alpha hat and beta hat. We have formulas for finding them. These are, we have scatter diagram and data plotting. These are the data plotting. As you see, these, if we draw a line like this, in this direction, we say it's positively correlated. But in this direction, it's negatively correlated, okay? We have positive slope. Here, and negative slope here. Okay. It's nothing actually. Okay. We now have a method of least square. We use least square for finding alpha and beta. We use least square for finding alpha and beta, beta hat and alpha hat. We say it's nothing. These are the derivation of the rules. It's not required from you. Only these are required from you. We say alpha hat is y bar minus beta hat x bar. So you must first find beta hat. Okay. Then beta hat is a sub xy divided by a sub xx. From the given data, we can get a sub xy and a sub xx. And in the given data, we have a list of data for x and a list of data for y. From each, we can get x bar and y bar. X bar is the sum of all data divided by the number of data. And y bar is the sum of all y data divided by the number of data of y. We see beta hat is a sub xy and is a sub xy divided by a sub xx. After finding this, and also we need to find y bar and x bar. After finding these two and beta hat, we can get alpha hat also. We can get alpha hat. As you see, alpha hat is y bar minus beta hat x bar. These are x bar and y bar. This x bar is the sum of all x data divided by the number of data for x, and y bar is the sum of all y data divided by the number of data for y. Here we have SXY and S sub XX. We use these two in finding beta hat. We say beta hat is S sub XY divided by S sub XX. S sub XY is the sum of XIYI minus a half of sum of X times sum of Y. Then S sub XX is the sum of xi squared minus the sum of xi minus 1 over n of the sum of xi all squared. This xi. That's why we have these rules only for finding the alpha hat and beta hat. After finding beta hat, we need to find x bar and y bar. From these three, we can get alpha hat also. We must first find alpha hat, beta hat, and then find alpha hat, because alpha hat depends on beta hat. As you see in the rule above, we have alpha hat is y bar minus beta hat x bar. And here we have S sub yy. S sub yy is the sum of yi squared minus 1 over n, the sum of yi all squared. Here, it's how to use that type of Casio calculator and finding these summations. You don't need it. We now have an example. We do it manually. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means n is 10. N is 10. Then, what should we find? We need to find this equation. It says, obtain the equation of the least square regression line. That means we need to have y hat equals alpha hat plus beta hat x. Okay. In this equation, we must have alpha hat and beta hat. We must find these two only. And we can get these two by the above rules. For beta hat, we must first find beta hat, then alpha hat, because alpha hat depends on beta hat. Here, we say alpha hat. First, let's find beta hat equals S sub xy divided by S sub xx. And alpha hat, after finding beta hat, we need to find X bar and Y bar also. After finding these three, we can get alpha hat, which equals to Y bar plus beta hat X bar. We just plug these three into the equation, we get alpha hat. Now, here, we are going to find beta hat. Beta hat is S sub xy divided by S sub xx, and this equals to minus 1.2667. Let me tell you how to find it. We have 20, 25, 30, 35, up to 65 for x. These are x data. We have 10 data for x and 10 data for y. We say for finding S sub xy, it equals to the sum of xi, yi plus. Is plus or minus? Let me check again. It's minus. Minus the sum of xi times the sum of yi. We find these. First, the sum of xi, 20 plus 25 plus 30 plus 35 up to 65. This equals 85. 5 times 85 is 425. That's it. Then the sum of these two, the sum of these all is, this is the sum of xi, and the sum of yi is the sum of all y data. 98 plus 87 plus 92 plus up to here. Let's say it is 500. Let's say that's 500. Okay. These are the sum of yi. How about the sum of xi, yi? We multiply these two, and these two, and these two, and these two, these two, these two, each one with the corresponding one. Then find the sum of them. Find the sum of multiplications. We multiply 20 by 98, then plus 25 times 87, plus 30 times 92, plus 35 times 79. We find these multiplications, and then we find the sum of them. Okay? We get a number. Let's say, please find the sum of y and yi. $681. And then we need to find the multiplication of these two corresponding elements. 20 times 98 plus 25 times 87 plus 30 times 92. Then we find the sum of them. We find the sum of them, of the multiplications. Let's say we get a number. It's going to be a huge number. Let's say it's 10,000. Okay. Let's say this is 10,000, and this is the sum of xi, and that's the sum of yi. We multiply these two, and then we subtract it from this value. We get a number, and that is, let's see, we get this value. That's it. Then we divide it by S sub xx. S sub xx is the sum of xi squared. Here we square all elements of xi. We square all elements of xi. The elements of xi are 20, 25, 30, 35, and so on. So the square of those elements is 400, and 25 is 625. 300 is 900. 30 squared. and 35 squared is 1225. 40 squared is 1600. 45 squared is 2025. Then 50 squared is 2500. And 55 squared is 325. And so on. Okay, we find these all squared. Then we find the sum of these all to get this one. And then again, what we do is it's minus 1 over n, which is 1 over 10, multiplying by the sum of xi all squared. We found the sum of xi squared, which is 425. Okay, and then we find this result. After finding this, we divide it. We divide the one which we found above here. The one which we found here, we divide it by this result here. The result that we get is beta hat, and equals to minus 1.2667. That's approach to 4 decimal places. Here, this is beta hat. After finding beta hat, we need to have beta hat, x bar, and y bar to get alpha hat. Here, we just work on finding alpha hat and beta hat, nothing else. We found beta hat, so we must find alpha hat also. How? We say alpha hat is y bar plus beta hat, so y bar minus beta hat x bar. Here we need to have x bar and y bar. We need to have x bar and y bar. We said this is 425. We divide by 10 because we have 10 data for x, and the sum of all elements of x is 425. We divide it by 10 to get x bar. And we divide 681 by 10 because we have 10 data for y, and the sum of all elements of y is 681. We divide it by 10, we get 68.1. And the above one is 42.5. These are x bar and y bar. X bar is 42.5. And y bar is 86.1. 68, sorry, not 86, I think. It's 681. Yes, I think. It is 681, so it's 68.1. It's 68.1. By dividing the sum of all elements of y by the number of data, which is 10, we get y bar. And for x bar, it's the same. We now have x bar, y bar, and beta. This is beta hat. We have these all. From these three, we can get alpha. We say alpha hat is y bar, which is 68.1 minus beta hat is minus 1.2667 multiplying by x bar. X bar is 42.5. We find this result, and the result is 121 point. This one. This is alpha hat, and this is beta hat. Okay, these are alpha hat and beta, and it's the end of the solution here. It's the end of the solution here, because we found the equation of the linear regression. We found it. That's it. Here we have another example. It says, refer to example 3, project the value of y when x to be 58. If you are asked to find the value of y when x to be that value, or the value of y when x to be this value, then what you do? You should first find this one. And then replace x or y by the given value to get the other variables value. We have given x, which is 58. We just replace here x by 58. Okay? We just replace here by 58. أجل هاتوا لبسيارة كيا. تنها داوي أمي بكردايا. عتنو مني بيشو كداوي أمي بكردايا. بيزو شيفين. بيزو أو يسألوا هربكين ويجوا هاو كوشي ما دسكين. إن جاء أو ما دسكين. Okay? We must have the equation. Then we can find the value of a value. Okay? That's it. Here we just replace x by 58 and we get 48.27. And here we have some tasks. It's for yourself. Look, these all are one data. 60, 63, 65, up to 100. You have 400s. Okay? أما ليرة هو area هذا تخبر وتعال بردام يك data. شن data ما هي بوك شن ما هي بوك and okay. And these are some tasks for yourselves. We now have tests of linearity regression. Yeah, we talked about these. I'm not going to talk about this again. Here we say beta hat, its estimation is beta. Here we use beta hat instead of beta. Before it was beta plus alpha x plus epsilon I. It is for x. It's for y. Y equals to this one. Okay, we say that. And then we write down the equation to become y hat equals beta hat minus alpha hat x. We say the estimation of this beta hat is beta. The estimation of it is beta. It's written down there. And also the variance for beta hat, the variance for beta hat, var of beta hat is partial squared by S sub xx. It's partial squared by S sub xx. We already have the formula for finding S sub xx. But for partial squared, we can get it from this one. Partial squared is 1 over n minus 2 times S sub yy minus beta hat S sub xy. We need to find S sub yy and also S sub xy. And we multiply, and we find the difference of S sub yy and b hat S sub xy. Then we divide by n minus 2. We divide by n minus 2, we get sigma squared. Sorry, not sigma squared, partial squared. And then we divide by S sub xx to get the variance of beta hats. So let's take a break and then we'll continue to finish this one. We now have testing procedures. For testing procedures, we have 4 steps. First, we need to write down the hypothesis. We need to write down the hypothesis. We have 2 hypotheses, null hypothesis and the alternative hypothesis. For null hypothesis, we always put beta to be 0. We always put beta to be 0 for null hypothesis. And for the alternative hypothesis, we say beta doesn't equal to 0. Beta doesn't equal to 0. This is the first step. In the first step, we just write down the hypothesis. And in step 2, we are setting the decision rule. Here in this step, we choose the method for solving, for finding the test. Here we have 2 methods. which are t-tests or one-way ANOVA. We use either these ways for finding the test statistic. Here we find the test statistic by either these two ways, t-test or one-way ANOVA. Here it's written that since n is always less than 30, that's why we use t-test. Okay. And here we also have one-way ANOVA. In one-way ANOVA, we use f-tests. Okay. In the second step, we just find that test statistic. That's either the t-test or f-test. Then in step 3, we are computing. That's what I said. Okay. We find t-test and also t-of. If we use t-test, we use t-test and t of alpha over 2 and n minus 1. Okay. In step 2, we find this one from the table. We calculate t from the table of data that we used in the previous lectures. Okay, in the previous topics. And if this t-test, but if we use ANOVA, here we have f-test. We find f from the table. The table should be given. Okay, the table will be given. We use it in step 2. We find f, and then for test statistic, we have a formula for each. For finding the test statistic, we find the test statistic. Okay, then we make in step 4, which is the last step. We are making the decision and conclusion. In the decision, we say it's either we reject H notes or we fail to reject H notes. We have only these options. We either reject H note or we have failed to reject H note. So we have only these 4 steps. In step 1, we just write down the hypothesis. In step 2, we find T and F from the table. And in step 3, we find the test statistic, which is a formula which will be given later on here for each. Then in step 4, we make the decision. And the decision is either rejecting H note or fail to reject H note. We now have t-test approach. As I said, we have 2 methods, one-way ANOVA or t-test. We have only these 2 methods here. It says here we have using t-test approach. For finding t-test, this is how to find t-test. This is t-test. Here we find this in step 3. That's in step 3. We find this. In step 2, you find T of alpha over 2 and n minus 1. That's in step 2. In step 1, that's the hypothesis. And in the final step, step 4, we make the decision. We use this for making the decision. Well, in this table, we say, we compare the steps 2 and 3. We compare the steps 2 and 3. If t-test, which is in step 3, is less than minus T of alpha over 2 and n minus 2. It's n minus 2, not n minus 1 actually. Sorry, it's n minus 2. And even the above 1, I said this n minus 2. We compare these two. If t-test is less than minus T of alpha over 2 and n minus 2, this could be obtained from the table. If it's less than, so we reject H notes. Even if t-test that we find from step 3 is the above formula, is greater than T of alpha over 2 and n minus 2. Even in this case, we reject the null hypothesis, I mean H notes. Okay? Then, if the hypotheses are like this, if H notes to be b to be 0, and h1 is 1. If h1 is greater than 0, I mean beta to be greater than 0, we have only one interval. We have one interval of the rejection. We say if t test is greater than t of alpha and n minus 2. If t test is greater than t of alpha and n minus 2, here we reject h0. That's in which case, if h0 to be beta to be 0 and h1 is beta to be greater than 0. And in the last case, we have only these three cases. It's case 1, case 2, case 3. In case 1, we say h1 decides which case should be used. Okay, which case should be used. If h1 is beta doesn't equal to 0, and here beta to be greater than 0, and here beta to be less than 0. We say if TTS is less than minus t of alpha and n minus 2, in this case we reject h0. Okay. We have an example. In example 5, it says considering example 3. In example 3, that's the example 3. I mean, this example 3. This example 3. In this example, we found s sub xx, s sub xy, s sub yy. We found these all. Okay. In this example, in example 3. Here we found beta hat, which is 1.27. N is 10 because we have 10 data for x and for y also. The sum of x is 425. The sum of x squared is 20,125. The sum of y is 681. The sum of y squared is 50,125, and sum of xy is 26,330. Then we need to find s sub xx, s sub yy, s sub xy. We need to find these. Why? Because here we have this rule. Okay. We say t-test for the test statistic is beta hat dividing by the square root of sigma hat squared dividing by s sub xx. Sigma is not given in the example, but we have a rule for finding sigma. Here above, we have this rule for variance. It's variance, which is sigma squared. It's a sigma squared. Sigma squared is 1 over n minus 2, multiplying by s sub yy minus beta hat s sub xy. So the most important thing here is to find s sub xx, s sub yy, s sub xy. If you have these data, these values, you can get these all by just using the rules. Look, s sub xx equals what? S sub yy, s sub xy. Okay, s sub xx is 3,000. S sub xx is 3,748.9. This is S sub xx. This is S sub xx. Okay. And we also have s sub xy and s sub yy. This is s sub xy. S sub xy is minus 2612.5. And s sub yy, this s sub yy, I don't know, it's not written down here, but you should have s sub yy also. After finding these all, we can get the variance. We can get the variance. The variance is partial squared over s sub xx. And here, partial squared is s sub xx minus beta hat times s sub xy dividing by n minus 2. And you already have this s sub xx, which is in the denominator. Okay? Look, partial squared is s sub xx minus beta hat s sub xy dividing by n minus 2, all multiplying by 1 over s sub xx. This is, and this one is here. So we get this rule. After getting this rule, we just plug in here and the values of s sub xx and s sub xy, those, okay? We just plug in here and we get the result. The result is, okay? This is the result. It's only calculations I leave for yourself, okay? Only by using calculator. Then in step 1, after finding these, then we start to follow the steps of solution. First, we state the null and alternative hypothesis. We state the null and alternative hypothesis. For the null hypothesis, we say beta to be 0. And for the null hypothesis, we say beta doesn't equal to 0. These are the null hypothesis and the alternative hypothesis. Then, in step 2, we determine the rejection region and state the decision rule. Here, we find, as you see in the example, it's given that using t-test, we also have given the level of significance, which is alpha. Alpha is given, and it's given that we use t-test. In step 2, we find t of alpha over 2 and n minus 2. N is 10, and alpha is 0.05. We get t of 0.05 over 2 and n minus 2 is 10 minus 2. 0.05 dividing by 2 is t of 0.025 and 8. We find this from the table. Do you need to go on the table to find this? It's easy. We talked about this a lot, okay? We find this one, and it equals to 2.306. This is the result. This is the result. It's 2.306. Now, we need to have the interval. We say if t-test, this is the test statistic, if it's greater than t of 0.025 and 8, or t-test to be less than t of minus t of 0.025 and 8. What's this? It's 2.306, and this is minus 2.306. We have this. If t-test to be less than 2.306 or t-test to be less than minus 2.306, we say we reject the null hypothesis. In these two cases, we will reject the null hypothesis. If not, we have failed to reject the null hypothesis. Then we calculate the value of test statistic. Now we find t-test. Look, t-test is beta hat minus beta bar, okay? Dividing by the variance of beta hats, okay? Beta bar is 0, it's not given, okay? And here we have minus 1.27 divided by the square root of variance of beta hat. Variance of beta hat could be obtained by this rule. Look, that's it. This is variance of beta hat. And the result is a value. It's a number. And the result here is, let me check. We just divide minus 1.27 by this square root. We just divide this by it. Okay? After obtaining this result, we compare this result with the result of the previous step. In step 2 and 3, we compare these two. We say, if the result in step 3 is greater than the result in step 2, or if the result in step 3 is less than the result minus the result of step 2, we say we reject the null hypothesis. If not, we have failed to reject. Here, Let's not write down the decision actually, because hence we reject the null hypothesis and conclude that the data provides sufficient evidence that the slope significantly not zero at this level of significance. Here in this case, we say it is less than. So t test is less than minus 0.306. It's less than this. That means we reject. Look, if we reject H naught, what's H naught? We said H naught is beta is 0. Okay? Beta is given. Look. Beta, we let it to be 0. That if it's not true, that means beta is not 0. Beta is not 0. Okay? That's all. And then we use the one-way ANOVA. One-way ANOVA for solving the same example in above. Okay? Here we say SST plus SSR equals SSE. Here SST could be obtained by this, which is S sub x, S sub y. Okay, SSR is this summation, which is beta hat times S sub xy. So even here we just focus on S sub x, S sub y, S sub xy. And SSE, it is the summation, which is SST minus SSR. I mean, after finding these two, we can get SST, because it's the difference between SST and SSR. That's all. Here, as I said before, we use F-test, and when we ANOVA, we use F-test for the hypothesis. You see, F-test is MSR dividing by MSE. MSR dividing by MSE, which is mean of squares. Okay? These two are mean of squares. We have this table. In the table, here we write down SSR. And here we write down SSE, which is the sum of square totals. Total of some squares is S sub yy. We find S beta hat times S sub xy here. And here we have SST minus SSR. And this is SST, which is S sub yy. Here we have degree of freedom. Degree of freedom. Degree of freedom for this one is 1. And for this one is n minus 2. And for this one is n minus. It's always like that. We just replace n by its value. If n to be 10, we say the first one is 1, the second is 8, and the last one is 9. And here we have MSR and MSE. We have MSR and MSE, which are the mean of squares. Then we divide MSR, I mean the above one, by the below one. We divide above one by the below one, the F-test. This is F-test. Look at this example. It's the same as the above one. Let's consider example 3. And it's given that H naught, I mean the null hypothesis is that beta to not be 0. And the alternative hypothesis is that beta doesn't equal to 0. We use the same, I mean similar to the above example, but here the method is different. Here we use one-way ANOVA, and in the previous one we use t-test. In one-way ANOVA we have F-test. Here we use F-test. Beta hat is this one, S sub yy, S sub xy. We have these. Okay, we calculate these. And then we compute all the sum of squares. SST, SSR, and SSE. We find these. SST is S sub yy. SSR is beta hat. We must find beta hat first, then multiplying by S sub yy. And then SSE is the difference between the above ones. The difference between these two. This SSE. After finding these, we now have the steps for hypothesis. First, we just write down the null and alternative hypothesis. We first write down the null and alternative hypothesis. Then, in step 2, this one. In step 2, we write down the F test, F in the from the table. We write down the rejection region. We say F tests. Here we find this one. F of 0.f of alpha and alpha 1 and 8. Alpha 1 and 8, which is alpha 1 and n minus 2. Alpha 1 and alpha f of alpha 1 and n minus 2. We can get this from the table, which is 5.32. We can get this. In step 3, we find F test. F test is the division of these two. It is the division of these two mean of squares, which is 16.5811. Now, in the last step, we compare these two results. We compare these two results. As F, we say F test, which is 16.5811, is greater than 5.32. So we reject H naught. If it's greater or less, if it's greater than f of alpha 1 and n minus 2, or if it's less than minus f of alpha 1 n minus 2, we reject the null hypothesis. In this case, we say it's in the rejection region. F test is in the rejection region. That means we reject H naught. That means here we reject H naught and we accept H1. In H1, we said that beta doesn't equal to 0. That means we say beta is not 0. Beta is not 0. Here we have a task, and then we have correlation. For the correlation here, we need to find R. For the correlation, we need to find R. If it says find the correlation, you must find R. R is S sub y dividing by S sub x times S sub y in a square root. We find R as correlation. It's the formula for finding correlation, to find the value of correlation. We say R is S sub y xy dividing by the square root of S sub x times S sub y. R must always be from -1 to 1. It must not exceed this interval. It must not exceed this interval. So it must not be greater than 1, and it must not be less than -1. We say if R to be 1, so you have a perfect positive linear relationship. But if R to be -1, we say it means that we have a perfect negative linear relationship. But if it's between them, so it's only its value. Look, as you see, R depends on the data, on the scatter plot. How they near to each other, R is bigger. Okay? We say, as you see, these data, for these data, we say R is 0.6C. So the correlation here, the correlation of these data is 0.6C. But for this one, as you see, if we draw a line like this, they are near to each other. They are near to the line. So it must be bigger. It must be bigger than this one. Why? Because these data are near to each other than the previous one. And if all on the same line, that means R is 1. As for the positive ones. And for the negative ones, look in this direction. If the data is in this direction, I mean, if it's in this direction, that means it's negative. So the correlation here is negative. And here, these data are away from each other than this one. So here, the correlation must be greater than this one. I mean, more or less than this one. It's minus 0.60 and it's minus 0.85. And these all are on the same line, on the same straight line. And in this direction, that means correlation is negative 1. And for these data, we see the correlation is 0. Why? Because, as you see, here we can draw a line like this, even in this direction, okay? We don't know in which direction should we draw the line. That means the correlation is 0. And for this one, if it's not linear, it's like this, it's a curve. And also we can say we draw a line like this or like this. We can get both negative and positive. No, it must not be from the origin. It could be from anywhere. If the line is in this direction, it's positive. But if it's in this direction, it's negative. But as you see here, we can get both. That's why we say its correlation is 0. And even we can say it could be obtained in this by this curve. And that curve is not a linear. It's not linear. So it's non-linear correlation. We have no linear correlation for these data. And for these also, we can draw both negative and positive. That means we have no correlation here also. In example 3, it says find the correlation. Here we find R. We already found S sub xy, S sub xx, and S sub yy. We already found these. We just plug in these here, the values of S sub xx, S sub yy, S sub xy here to get the result. So the result is minus 0.9395. This is the correlation for the given data in example 3. And these are the Excel ones. For the Excel, if you want to use Excel sheet, in solving these examples, let me take Excel sheet. Let's write down some data. Let's see, 1, 3, 2. Okay, let's see, we have these data. These are for X and for Y. Okay, if you have these data for X and these for Y. And do you see it? Okay. I think that's not gonna be appear in the report. Let me share the screen here. Okay. If you have these data for X and Y, and if you want to find the I mean, if you want to test it, yeah, what we do? We say, we first click on data. In data, we have data analysis. We choose data analysis. Then, in data analysis, we scroll down to get regression. We scroll down to get the regression. Then, we click on it, and then okay. Then, we have this box. In this box, in the first box, we have input Y range. We must write down what are the Y values. As you see, Y is starting from here to where? We just select them all. These are Y data. And then For X data, we click on box of X data, yeah, and we select the X values. That's all. Then here we click on output range. Output range. Where do you want to show the output? I'm just gonna click on here. I want to give me the result. Sorry for that. Here we click on this one on the box, inside the box, and then just click on somewhere to get the result from that box to that. Okay, now once I click on OK, the result comes. That's it. This is the result. Okay, that's how to use ANOVA in solving regression. It's always used by ANOVA. Okay, we have two methods for solving regression, linear regression, which are ANOVA and t-test. Okay, each example could be solved by both methods, but if in the exam it's selected which of the methods should you use the one which is selected. Okay, but if not, you are free to use any of these. When you use computer, I mean Excel sheet, Excel for solving regression, linear regression examples, it's always done by ANOVA. It's always done by ANOVA. So that's it. And it's the end of today's lecture and even the course.